So did you know that by the second quarter of 2026, 62% of Fortune 500 companies are projected to be piloting AI agents?
I mean, wow. 62% is a massive jump.
Right. And we are not just talking about testing, static chatbots here. We mean actively letting autonomous software run critical operations.
Yeah, which is, well, it's a terrifying thought for a lot of people.
Exactly. So here is a question for you listening to consider as we start. We are giving software the autonomy to make decisions, but what happens to your business when one of those autonomous agents actually breaks the law?
Yeah, that scenario is basically the phantom menace keeping European executives up at night right now.
Oh, I bet.
Because we are moving incredibly fast into a space where software isn't just, suggesting an action, it's actually executing it without a human clicking approve.
Which brings us to the real mission of today's deep dive. We are unpacking the AI Agents and Multi-Agent Orchestration Enterprise Guide 2026.
Right, the one published by AetherLink.
Yep, the Dutch AI consulting firm. So if you are a European business leader or a CTO or a developer listening right now, our goal today is to give you a clear, actionable roadmap for evaluating AI adoption.
And we're completely skipping the hype cycle here.
Totally. We're looking entirely at the architectural and regulatory reality of deploying these systems today.
And we really need to ground this in why the timing is so critical, right? Like, we are in the middle of a massive technological transition. The era of the reactive chatbot, the systems that dominated 2024 and 2025, that's basically ending. We are moving to a paradigm of autonomous AI agents that can execute complex multi-step workflows completely independently.
Right.
But alongside that technological leap, the regulatory net is tightening. The EU AI Act enforcement deadlines are, well, they're hitting hard in 2025 and 2026.
And the economic stakes for Europe are just massive here. I mean, looking at the global landscape, the AI market attracted $21.8 billion in venture funding in 2025 alone.
Which is staggering.
It really is. And European startups are capturing a significant chunk of that capital, especially in compliance first solutions. But if you look at the Stanford University AI Index report, the actual commercial value being generated for the revenue and the operational savings, it's still heavily skewed toward the US and China.
Right, so the innovation is happening locally, but the financial rewards are bleeding outward.
Exactly.
So mastering compliant AI agents isn't just an IT infrastructure upgrade. It is a strategic imperative. For European enterprises to reclaim that commercial value, they have to deploy these autonomous systems securely and, crucially, legally
Yeah.
before that regulatory window closes.
Okay, so let's unpack the technology first, because to really grasp the regulatory risk, we have to understand the nuts and bolts of the shift from chatbots to agents.
Yeah, let's break that down.
So here is how I kind of process the difference. A chatbot is essentially a highly advanced calculator. It's incredibly smart, but it only calculates when you punch in the numbers and hit equals.
Right, you ask a question, it generates an answer, and then it immediately goes back to sleep.
Exactly. It has no memory of what it just did unless you specifically remind it.
Because it is entirely turn-based and reactive.
hmm
It relies 100% on human prompting to advance the workflow.
But an AI agent operates more like hiring a junior project manager. You don't ask it a single question, you give it a broad goal.
Like, audit these expense reports.
Yeah, perfect. The agent then manages its own task queue. It decides on its own to open an external database, query the company policy, compare the numbers, and flag anomalies.
It maintains context and actively learns across different sessions.
Right, it just operates continuously until the goal is met.
And the underlying architecture making that junior project manager autonomy possible is really fascinating. The AetherLink guide highlights orchestration frameworks like LangChain and Crew AI, alongside, tool use APIs from providers like Anthropic.
Wait, let's pause on those terms for a second. For a business leader who isn't, writing Python code every day, what exactly are LangChain and Crew AI? Like, if the large language models say GPT-4 is the engine of a car, are these frameworks the steering wheel?
I'd say they're the steering wheel and the transmission combined.
Okay.
Because a raw language model just predicts the next word. It can't natively click a button on a website or open a spreadsheet.
Oh, right.
So frameworks like LangChain act as the connective tissue. They allow developers to give the language model tools. So the model writes a line of reasoning, decides it needs to search a database, and LangChain translates that intent into an actual software command that runs the search.
Ah, I
And then
see.
Crew AI takes that a step further by letting you define specific roles for different agents so they can hand tasks off to one another.
Okay, that makes sense. But the engine and the transmission still need a map to know where they're going, especially inside a private company.
Yes,
Yeah.
absolutely.
And the guide points to AirAg Retrieval Augmented Generation as the real game changer for enterprise adoption. So, to use another analogy, if a standard AI model is taking a closed book exam based on whatever it scraped from the public internet years ago, AirAg basically turns it into an open book test.
Which fundamentally solves the hallucination problem.
Right.
Because a standalone language model out of the box has zero visibility into your company's proprietary secrets. It does not know your specific HR policies or your supply chain vulnerabilities or your past customer case histories.
So how does RAG actually work under the hood, though? Because it's not just, uploading a PDF to ChatGPT.
No, not at all. Think of RAG as an ultra-fast, intelligent librarian sitting between the user and the AI.
Okay.
When the agent receives a task, the RAG system instantly scans your company's private, encrypted databases, what we call vector databases.
Hmm.
It finds the 3 or 4 specific paragraphs from your internal documents that are actually relevant to the task and feeds only that specific information to the AI model alongside the prompt.
Wow. So the AI is forced to reason using only your company's highly secure, carefully curated book.
Exactly.
And that solves two massive enterprise problems. First, domain-specific reasoning. The agent is making decisions based on your actual approved business rules, not just generic web data.
Yep.
And second, data freshness. Because our RAG connects to live databases, the agent acts on inventory levels or compliance rules from 5 minutes ago, not from some training cutoff date 2 years ago.
And the broader implication of RAG is auditability.
Mm.
Because the system retrieves specific documents, you have a digital paper trail.
Oh, that's huge.
Yeah, you know exactly which internal file the agent referenced to make a decision.
Right.
And that traceability is the bridge directly into the regulatory ticking clock.
Right.
Because autonomy requires guardrails. If we're letting software act independently, we have to prove to regulators exactly how it arrived at its conclusions.
Which brings us right to the EU AI Act deadlines. We are looking at a phased enforcement approach here. By Q2 of 2025, transparency and documentation requirements activate for all high-risk AI systems. And by Q3 of 2026, we see full enforcement. And that targets critical sectors like healthcare, criminal justice, financial services, and employment.
And the penalties for noncompliance are severe. We are talking about fines of up to 35 million euros or 7% of global annual turnover, whichever is higher.
Okay, I have to play the skeptical CTO here for a minute.
Go for it.
I hear things like transparency documentation, bias testing, and logging every single decision an AI makes. If I'm trying to compete with a lean, aggressive startup in the US or Asia that just doesn't have these restrictions, this sounds like a bureaucratic nightmare.
I get that.
I mean, I'm imagining having to run every single automated decision past a compliance checker, which doubles my latency, spikes my API costs, and completely throttles my speed to market. How does AetherLink justify that massive trade-off?
Well, the knee-jerk reaction is definitely to view compliance as a speed bump. But the source material completely rejects that premise. Yeah, AetherLink's philosophy is that treating compliance as a bolted-on post-development checklist is a massive strategic failure. They argue that in B2B environments, compliance is actually the ultimate competitive advantage.
Okay, I need you to explain the mechanism of that advantage because to a developer, adding oversight layers almost always equals friction.
Right, but consider the procurement cycle. If you are selling an AI solution to a regulated entity, say a major European hospital network or a multinational bank, their legal department is going to audit your tool.
Oh, for sure.
If your AI is a black box, that procurement process stalls for 6 months and honestly often dies completely. The client just cannot afford the liability.
Makes sense.
So AetherLink proposes using their strategic framework, AetherMind, to map the regulatory requirements first. Then, through their development practice, AetherDV companies build what they call natively compliant agents.
Ah, so you bake the rules into the foundation of the architecture from day one rather than trying to tape them onto the walls after the house is built?
Exactly. And when you build a natively compliant system, you sail through vendor risk assessments. You win enterprise contracts that your less compliant competitors are completely locked out of.
Wow.
It also reduces remediation risk down the line, meaning your engineering team isn't constantly pulling down the system to patch compliance failures. And a crucial architectural feature of these natively compliant systems is the implementation of break glass protocols.
Break glass protocols, like
Yeah.
pulling a literal fire alarm on the factory floor when a machine malfunctions.
Yep.
But how does a company actually build a fire alarm for software that thinks for itself?
It requires designing the system with hard-coded circuit breakers. The agent is continuously calculating a confidence score for its own actions.
Okay.
If an agent receives a prompt that exceeds its defined guardrails, or if it encounters a truly novel, high-risk situation where its confidence score drops below a set threshold, the system automatically halts.
This stops.
It freezes the workflow completely and instantly routes a summary of the situation to a human operator's dashboard. The human intervenes, makes the critical judgment call, and then the agent resumes.
So the autonomy has a strict leash.
Exactly.
That makes sense for a single agent. But the AetherLink guide takes this further, and this is where the system design gets really complex. The guide states that a single monolithic agent, one giant AI brain trying to handle intake, processing, compliance, and routing all at once, is a myth for the enterprise.
Yeah, it hallucinates, it gets confused by massive context windows, and it just fails.
Right. The future is a team of specialized agents working together.
But building a multi-agent system raises a massive logistical challenge. I mean, how do you get 5 or 10 different autonomous AI programs to collaborate without creating total chaos, redundant API calls, and infinite feedback loops?
It sounds like a mess.
It can be, but the solution AetherLink details is the agent mesh architecture.
Okay, let's break down the agent mesh.
So instead of agents shouting at each other point to point, the agent mesh is a centralized management layer. Think of it like the head expediter in a massive, high-end restaurant kitchen.
Oh, I like that.
The expediter doesn't cook the food, they manage the flow of information. The mesh handles service discovery. So if the data extraction agent finishes its job, the mesh knows exactly where the validation agent is and hands the data over.
Nice.
It also handles load balancing. If one agent is overwhelmed with 10 tasks, the mesh spins up a duplicate agent to handle the overflow. And crucially, it handles governance, enforcing those break glass protocols across the entire network.
Let's bring this out of the abstract with a practical example, because the healthcare case study in the AetherLink guide perfectly illustrates how this expediter mechanism works in reality.
It really is.
They worked with a mid-sized European healthcare network that was completely drowning in patient intake forms. Medical administrators were manually reviewing 50 to 100 complex intake forms every single day.
And the manual review process in healthcare is notoriously fragile. It's tedious, highly susceptible to human error from fatigue, and creates massive bottlenecks in patient care.
Totally. The clinic was wasting over 40 staff hours a week just categorizing information, checking for missing signatures, and routing the forms to the appropriate specialty departments. So AetherLink deployed a multi-agent orchestration system using their AetherBot framework.
And they didn't just deploy one massive healthcare AI.
Right. They deployed a specialized team of 5 distinct agents.
This is the perfect showcase of the separation of concerns. How do they divide the labor across the mesh?
Well, the handoffs are fascinating. First, a new PDF hits the server. The mesh wakes up the intake agent. The intake agent's only job is to read the unstructured PDF using RAG, extract the relevant data, and write it into a clean JSON file.
Okay.
And the millisecond that JSON file is generated, the mesh triggers the validation agent. The validation agent doesn't read the PDF, it just looks at the JSON file and cross-references it against EU medical documentation standards to ensure no required fields are blank.
Decoupling the extraction from the validation is brilliant because if the validation fails, you know exactly which agent dropped the ball. It makes debugging infinitely easier.
Yep.
So what happens next?
This is where the clinical value really shines. The mesh passes the validated data to the risk agent. The risk agent analyzes the clinical history to flag concerning symptoms or comorbidities, say, an allergy interacting with a stated condition for immediate human review.
Wow.
Next, the routing agent takes the profile, looks at the live schedules of available specialists, weighs the condition's severity, and assigns the case.
And presumably there is an oversight mechanism watching this entire relay race, right?
Yes. The 5th agent is the compliance agent. It sits above the workflow, monitoring the data packets moving between the other 4 agents, ensuring every single step adheres to GDPR and medical confidentiality standards. It literally strips personally identifiable information before any external API calls are made.
The level of orchestration required to make that fluid is immense. What was the actual business impact for the healthcare network?
The results were staggering. They went from hours of manual labor to processing a batch of 50 complex forms in just 8 minutes.
Wait, really? 8 minutes for 50 forms?
Yes, and the quality didn't drop. They achieved a 96% accuracy rate compared to baseline expert human review.
That's incredible.
And the remaining 4% of forms where the AI was unsure, those triggered the break glass protocol. The mesh automatically flagged them and sent them to a senior administrator's dashboard for human verification.
You know, that 4% is just as important as the 96%. It proves the guardrails actually function in a production environment.
Absolutely. And the financial kicker is incredible. They recovered the entire development and deployment cost of the multi-agent system in just 4 months, strictly through labor savings.
Wow.
35 staff hours a week were freed up, allowing those administrators to shift from data entry to actual patient coordination and clinical support.
The ROI is undeniable there. But, we do have to introduce a harsh reality check here.
Always a catch.
Yeah, the healthcare example sounds like a perfect utopia, but the economics of multi-agent systems can be brutal if they're mismanaged. CTOs need to look very closely at the actual cost of running an entire mesh of communicating AI agents.
Okay, let's do the math on that, because my immediate thought is the API bill. If I have 5 agents talking to each other and a single complex workflow might invoke a large language model 5, 10, maybe 15 times to reason through errors. I mean, those API calls are going to multiply exponentially.
They snowball rapidly. The AetherLink guide explicitly warns that traditional machine learning benchmarks are effectively dead when it comes to evaluating enterprise agents.
You mean metrics like F1 scores?
Exactly.
For our business leaders, an F1 score is basically an academic metric that balances precision, how many of the AI's answers were right, with recall how many of the total right answers the AI managed to find. It's right for research papers, but why is it dead for business?
Because an F1 score doesn't tell a CFO how much money the system is burning.
Fair point.
All right. When software has autonomy to loop and retry tasks, the evaluation metrics must shift to business outcomes. CTOs now have to track 2 vital metrics. Task completion rate, meaning does the agent actually finish the job without human intervention, and cost per task.
So let's talk real numbers on cost per task. How much are we spending every time this mesh runs a workflow?
Well, for a very simple single-step task, like having an agent classify whether an incoming email is a complaint or a sales inquiry, you might spend between 1 and 5 euro cents in compute costs.
Okay, that is highly manageable.
It is. But for complex multi-step reasoning, where agents are using tools, querying databases, and verifying each other's work, the compute cost jumps to between 20 cents and a full euro per task.
Wait, up to a full euro for one task?
Yes.
Think about the scale of a mid-sized enterprise. If a hospital or a logistics firm is processing 10,000 automated tasks a day, and we average 50 cents a task, that's 5,000 euros a day. We are talking about hundreds of thousands of euros a year just in inference costs. That could easily eclipse what a company is paying for its entire foundational cloud infrastructure on AWS or Azure.
Token spend becomes the primary budget driver. When agents are passing massive context windows back and forth, you are paying for every single word generated and processed. However, the source material doesn't just present the problem, it provides actionable optimization strategies.
Okay, good.
You do not have to accept a ballooning cloud bill as the cost of doing business.
Looking at the guide, they suggest semantic caching. If I understand the mechanism correctly, this is essentially giving the AI a permanent scratch pad. If the routing agent has already done the complex math to figure out that Dr. Smith is the best specialist for a specific type of knee injury on Tuesdays, it saves that logic. So when a nearly identical intake form comes in the next day, the agent retrieves the pre-computed answer from the cache instead of paying the API to run the entire reasoning engine from scratch again.
That is exactly how it works. You stop paying the AI to solve the same problem twice.
Love that.
The second major strategy to rein in costs is right-sizing your models. Developers have a habit of using the most massive, expensive model available, like GPT-4o or Claude 3.5 Sonnet, for every single step of a workflow.
Guilty as charged.
Right. But the guide argues this is a massive waste of resources.
So how do you distribute the workload?
You route based on complexity. For the initial basic filtering, like the intake agent extracting names and dates from a standard form, you use a smaller, highly efficient open source model, like Llama 3.18b.
Right.
It costs fractions of a cent. You only invoke the expensive heavy hitter models when the workflow hits a wall, requiring deep, complex reasoning. like the risk agent analyzing conflicting clinical symptoms.
So you let the cheaper junior AI do the heavy lifting on the administrative tasks, and you only tag in the expensive senior partner when the nuanced expertise is absolutely necessary.
Precisely.
By implementing that kind of model routing alongside semantic caching, the guide states organizations are cutting their total agent costs by 30 to 50%. It transforms the economics from a potential budget breaker into a highly viable, scalable solution.
It is the difference between a successful enterprise deployment and a pilot program that gets shut down after a month because the CFO saw the API bill.
Absolutely. Well, we have covered a massive amount of ground today, moving from the regulatory constraints to the architecture of the agent mesh, and finally, the hard economics of API costs.
We sure have.
Let's distill this down for the audience. For me, my number one takeaway from the AetherLink guide is that the single monolithic AI is a dead end for enterprise applications.
Yep.
The future isn't one giant all-knowing brain, it is multi-agent orchestration.
Yep.
Building specialized AI teams that hand off tasks securely and logically, managed by an expediter layer, is the only way to achieve reliability at scale.
I agree completely with that architectural shift. My biggest takeaway centers on the business strategy. The EU AI Act is not an IT problem. It is a board-level strategic mandate. Waiting until the end of 2025 to figure out your compliance posture is a recipe for massive regulatory fines and being locked out of enterprise procurement.
So true.
Embedding governance, break-glass protocols, and RAG auditability into your architecture today is what will separate the market leaders from the companies scrambling to survive in 2026.
It really is a critical window of opportunity. I want to leave you, our listener, with a final thought to mull over as you look at your own company's roadmap. We have spent this time analyzing how your internal agents communicate with each other and how you maintain control over your own mesh. But zoom out and think about the year 2027.
Oh boy.
Think about what happens when your company's autonomous AI agent negotiates a vendor contract or attempts to resolve a complex supply chain dispute directly with another company's autonomous AI agent. When two distinct AI systems, trained on different internal rules, shake hands and make a binding agreement in the digital dark, who is ultimately legally responsible when one of them makes a mistake?
The intersection of multi-agent autonomy and corporate contract law is going to be the next great frontier.
It's going to redefine how business is done entirely. For more AI insights, visit etherlink.ai.